So our learning goal today, I can graph a quadratic function. We're still using the vertex y-intercept method per se. In other words, we're not using the table method. But here's the deal. Sometimes, and this isn't going to happen in all of your homework, but I'm introducing that this is what could happen. So what happened in the previous two assignments could happen, or it could end up where the vertex is also the y-intercept. Well, if the vertex is also the y-intercept, how many points do we have so far? Just one. We're not going to have the easy get the second point from the y-intercept and reflect it, and now we've got 3. So if the vertex is the y-intercept, how many x values do you suppose you're going to have to choose? 2, because then that will give 2 points that you can then reflect, and you will now have all 5 of your points. So today you're going to have to find, when we're practicing these, we're going to find the vertex, and we're going to discover that it turns out to be the y-intercept also, and then how are we going to pick those other 2 x values that we need from that. So let's do this first one. Graph y equals x squared minus 6. Okay, what's our a value? 1. B?
0.
0. There are no x's. So 0 times x, that wiped out the x's. And c is? Negative 6. Okay. So to find the vertex, we need the b and the a, right? So we're going to substitute in. We have the opposite of 0 is for our b value. 2 times 1 downstairs. X equals? The opposite of 0 over 2.
0.
And 0 divided by 2 is 0. And 0 is its own opposite, right?
Yep.
So x equals 0. So for our vertex, we now know that the x value is 0 because this is our axis of symmetry too, isn't it? So where would you be drawing right now? If I told you to draw down on the graph already, if I told you to draw the line, the axis of symmetry, where would it be? Be going through the origin? X equals 0. What kind of line?
Substitute 0 in for equation.
I don't want us to find the vertex right now. I just want us to draw the axis of symmetry. So I want you to do it right now. I want you guys all to draw the axis of symmetry for this on that graph right now. Go down to the graph. We just found the axis of symmetry. There it is. It's x equals 0. Where's it at on the graph? Where's it at on the graph? Axis of symmetry. We don't even really have to find the whole vertex to be able to draw the axis of symmetry. That could very well be the first thing that we do. Okay, I'm going to say that if you don't draw it right here on the y-axis, oopsie, I didn't do a very good job there though. If you did not draw it right here on the y-axis, you do not have it in the right location. So the vertex is going to be on the y-axis, isn't it? The axis of symmetry is x equals 0, which means it has to cross the x-axis at 0, which means it's actually the y-axis. It's right on top of the y-axis. Okay, now let's go do what Noah wanted us to do. He wanted us to find the y of the vertex. So find y, and we know that x equals 0 for our vertex, right? So we're going to sub into our equation, which is what? Y equals x squared minus 6. 0 to the second power. 0 to any power is 0. If you just keep multiplying by 0, you're going to keep getting 0. So what's the y value of our vertex? Negative 6. So we just found our vertex. It is ordered pair 0. Oh, I didn't mean to put a parenthesis there. It is 0, negative 6. Well, since c is negative 6, right? Isn't c negative 6 in this problem? Since c is negative 6, the vertex is the what? Y-intercept. It's got 2 roles. It's not only the vertex, but it's also the y-intercept. Ooh, shoot, there goes our second point. We got, this one's stealing
So let's go put that on our graph. Ordered pair 0, -6.
That's our vertex, also known as our y-intercept. The vertex we can't reflect, right? Y-intercept we can reflect, but if we reflect this, where would we reflect it to? Same spot, it'd be right on the same spot. So we can't have a reflection point for the y-intercept this time, because the y-intercept is the vertex, and the reflection point for that would be itself. You can't move off of the axis of symmetry. Nope, you can't flip it up. That would be called, then what we'd be doing is we would be doing a reflection over the x-axis, and we don't want to reflect over y equals 0. We want to reflect over x equals 0. So if we flipped it up, we'd be flipping over that, wouldn't we? Over a horizontal line. So we can't do that. That's a good thought. If we wanted to do reflect over the x-axis, we could. But we got to reflect over the y-axis. So here's the deal. The only x value we've used up is 0, right? So now when we pick our other x values, it says right here, we'll have to find 2 other points. Would you put a box around that so you could make that very clear to yourself that when the vertex is also the y-intercept, you're going to have to pick 2 more x values on your own. I've already chosen them for us. I said when x equals 1, because to the right of this point would be x equals 1. So we'll put 1 in and see what happens. Y equals 1 squared, take away 6. Y equals 1 take away 6, because 1 squared is 1. What does y equal? -5. So what ordered pair do we have now? One, -5. Okay, let's go put that point on our graph. 1, -5. Oh, it's really close to the vertex. What are we going to do with that point? Can that one be reflected?
Yes.
Will it land back on itself? No, it's going to be over on the other side, equal distance away, right? Now we got 3 points. So now we pick another x value. X equals 2 is what I've chosen for us. So let's do when x is equal to 2 in our y equals x squared minus 6. So y equals 2 squared, subtract 6. Y equals what? 4, take away 6. Y equals -2. I got some of you not doing this with us. I don't know why. You already got this. You're amazing. Okay, that's awesome. Okay, so ordered pair what? 2, -2. So we're going to go to 2 and -2, and our points actually end up pretty close to each other. We end up with kind of a small u here, but okay. We know that our U-shaped graph still goes on up. So have you discovered a way that helps you draw these curves better than, it's kind of hard to do. Have you discovered to draw these U-shaped graphs? Now I can't turn my, I could rotate this, but I like to turn my paper over if I have to, and I like to start at the vertex and work my way out from the vertex. And with my, some of you guys, your papers are kind of looking like there's no symmetry going on. It looks kind of that U-shaped graph. You can't tell that there's a mirror image happening because it looks a lot skinnier on one side of the axis of symmetry than it does on the other. Okay. Anybody think right now there's any work we could have saved ourselves here? Cody.
We know that 0 to any power is 0, so we could just get that step.
Which step?
On x equals 0 to second.
Here, right here?
Yeah.
Okay. Oh, I want to get way more work than that. I'm even lazier than that. Any part of this we could have just totally left out and said, you know what? Here's what I can assume should happen. No? we turn it into a what?
a fraction where b was over 2.
So here, this part right here,
Yeah,
we didn't even need to do this, you're saying?
yeah,
Because why?
because we got our vertex when
When we found our vertex, it ended up being the what? Y-intercept. When do you think we can assume that will happen?
Whenever zeros.
whenever you have 0 as your b value.
Yeah. Because what's going to happen when you have a 0 upstairs?
It's
What
gonna be
happens when you
0.
try to divide 0 by something?
It's
0?
always gonna be
It's always going to be 0, isn't it? So you're always going to end up with 0 for your x value. And what points always have that 0 as their x values? What
Let's
points?
see.
The C, all the y-intercepts. All the points on the y-axis have a 0 for an x value. So I'm thinking that if we're going to test one more out just to make sure, but I'm thinking that we might be able to take a shortcut. So Noah just said when b is equal to 0, and maybe some of the others of you were saying it also, when b is equal to 0, maybe we can skip this vertex step. Maybe we can just go plot the y-intercept and draw a line axis of symmetry through it saying, you know what, that y-intercept is also the vertex.
Okay, let's go to the backside and see if it happens again. Because sure enough, what's b equal to in this one? 0. Let's just verify that it happens. So let's find our vertex. We'll just go through the steps, Make sure we can take this shortcut. So x equals the opposite of b over 2a. X equals the opposite of 0 over 2 times negative 2. X equals the opposite of 0 over negative 4. What's x going to equal? X is going to equal 0.
Are you starting to see why that has to happen every time when b is 0? Does it matter what's downstairs? No. When we take 2 times the a value, remember a can never equal 0, so we're never going to have 0 downstairs. So we're always going to be dividing by something other than 0 into a 0 upstairs. And whenever you take 0 divided by something, you're always going to get 0. So right now, when we put this into our equation, negative 2x squared plus 4, let's see what happens, because we think we know what should happen. So y equals negative 2 times 0. Well, anything times 0 is 0. It's gone. Y equals 4. Why looky there? We got the y-intercept, didn't we? So since c equals 4, the vertex is the y-intercept again. It happened again. Okay, well, let's go put that on our graph. 0, 4. What should this parabola do? Open up or down? Down, so we have a negative a value, okay? Well, axis of symmetry, get it drawn. It's kind of hard to see, I know, I get that when it's on the y-axis because that's already darkened. But if you extend it above and, if you extend it above and below with the dotted line, the dashed line, then you can tell that you're also making the y-axis into an axis of symmetry. Because we want to reflect over it. Yes?
When we do the axis of symmetry, if we know that it's going down, can we just put it going down?
Just from that point down instead of all the way? Sure. Okay, any other questions so far? Okay, now let's go, we gotta pick some x values so we can get another point and then be able to reflect it, because altogether we need how many points? 5. I know some of you have been trying to get away with 3 every now and then. So which x value do you want to pick? 1? Okay. When x equals 1, so y equals negative 2 times 1 squared. You guys go ahead and do your own work because you know how.
pair 1, 2. You agree with me? Okay, reflect it after you graph it.
Negative 1, 2.
Negative 1, 2, yeah. Okay, you pick another.
2.
2? You like 2? You don't want to do 3? Okay, let's do 2 then. How many of you have discovered that sometimes you pick X values that give you a Y value off the graph? Has that ever happened to you? Yeah? Yeah. But you know, it's okay. Sometimes that's just what happens. So when X equals 2, you said. Okay, so let's go find the Y value for when X equals 2. I get order pair 2, negative 4. Agree? Disagree? Agree? Reflect it. Negative 2, negative 4, right? And draw your parabola. Whoops, I just did what I said you guys do. Kind of sloppy. Okay, conclusion. When b equals 0, what are we going to say?
The vertex is going to be the y-intercept.
Okay, the vertex is also the y-intercept. Happened twice, we're feeling pretty confident about it, right? You don't want to impress, you want to make sure. Okay, questions, anything? Or are we going to work on homework? I'm going to do the first one in the homework with you. Show you how you can shortcut these then, okay? Anybody have any questions? Oh, what were we going to do with those? I don't even remember now. Oh, let's put some in and make sure that, let's practice some more. Okay, go. Get your, the graphing calculators I asked you to turn on. Let's try some more. Let's do just a couple, just to make, let's do the conclusion. It said, get a graphing calculator. Yeah. Thank you. Because I do want you to see that we can make this conclusion. So, turn them on, y equals, anything that's in y equals, clear it out. Anything in y equals, clear it out. And I want you to put in the following equation, okay? So I'm not going to use any of the ones that we have here. I want you to put in 3x squared plus 1. So the x is next to the alpha key. You can't just press the x squared key, it will just square the 3. So 3, and then the x key next to the alpha key, and then square it with the x squared key, and then plus 1. And then do a zoom 6. In other words, it should take you to a nice graph, hopefully. Is the vertex on the y-axis?
Yes.
Okay, why is it? 3x squared plus 1. B is equal to 0. Okay? You give me an equation where B is equal to 0. A quadratic equation where B is equal to 0. Go back to y equals. Let's clear out the one we put in there. Come on, do it with us, because I want you to be able to use these graphing calculators. Tomorrow I say we're going to correct our homework with them. You're going to be able to do it. So put in a quadratic function in there that doesn't have that its b value is 0. You make it your own. Graph it and see if it's sitting on its vertex is on the y-axis. So, Faith, what's yours? What's your equation?
7x squared plus 1.
Okay, 7x squared plus 1. And that one turned out its vertex on the y-axis. How about you, Abby? What's yours? Okay, negative 4x squared minus 3. And did that one end up with its vertex on the y-axis? Yes. Okay, how about you, Noah? What do you have?
Nothing on, oh, because you probably use such big numbers that it's not doing this. So do a zoom, 0. See if it'll show up. That's a zoom fit, see if it'll show up that way. Does that do anything for you?
She said it was
Or maybe 10, I don't know. Okay, Tori, what's yours?
I did x squared minus 6.
X squared minus 6. Is the vertex on the y-axis? Okay. Where at? Where at? What do you think the order, what do you think the vertex is for that one? Okay, I want everybody to go to the vertex for theirs. What's the vertex of your, just look at the equation, don't even look at the graph. Go back to the equation, look at the equation, and make a decision. What's the vertex?
-4.
No, it's an order of terror, remember?
0, -4.
0, -4, 0, -3, 0, 1. So in other words, it's the what? It's the y-intercept. It's the number that you're adding or subtracting at the end. That's the y value. It's going to be order pair 0. So what should your vertex be, Tori? Since it was x squared minus 6, what would your vertex be? 0, -6, right? Okay, let's go ahead and put those back now, and then I will help you see how you can shortcut your homework sometimes.